Hello everyone. So in this video, I will solve 5 MCQs of this paper 9702, paper 1 to October, November 2021. So let us start. Question 6 is, the graph shows variation with time t, the velocity of vehicle moving in a straight line. So this is velocity time graph. On vertical axis, we have velocity, and horizontal axis, we have time. The vehicle moving at 4 meters per second begins to accelerate at t equal to 0 second. What is the vehicle acceleration at t equal to 3 seconds? You know that what we have to find acceleration at t equal to 3 seconds. And how you find acceleration from velocity time graph? You know that the gradient of velocity time graph gives you acceleration. This is gradient of velocity time graph is equal to acceleration. And over here, we have to find acceleration at t equal to 3 seconds because velocity time graph is curved. So acceleration is changing, acceleration is different at different points. So that's why the time is specified, that is 3 seconds. So what we will do, we will draw a tangent at t equal to 3 seconds. So I have already drawn a tangent at this point. The tangent is a line that that touches this curve at single point. So that is at 3. So what we will do, we will find the gradient of this tangent. So I will take 2 points on this line, and probably I will select those 2 points which are in whole numbers. So what I am going to do, I am taking this 1 point, and this point is another point, and then I will draw triangle on this line, and I will find the ratio of this vertical side, that is delta y, and this horizontal side, that is base, this is delta x. You know that gradient is delta y over delta x, that is rise over 1, the ratio of rise over 1. So what is the value of delta y over here? You know that on vertical axis we have one small deviation as 2 meters per second. So we have 2 small deviations on vertical axis. So we have 4 meters per second divided by the time is in second, and on horizontal axis we know that one small deviation is equal to 1 second. So we have 3 small deviations over here, 3 boxes over here. So each box is equal to 1 second. So we have 3 seconds. Okay. So 4/3 will be equal to the approximate gradient in this case. So that is equal to 1.333 meter per second square. Okay. So which option is closest to this value? You know that this is wrong, this is wrong. So C is correct for this question. D is also wrong. So you have to draw a gradient carefully, and tangent carefully. Tangent should touch only at 3 seconds. Okay. Then you will choose 2 points on this straight line, and then you can use the ratio of rise over run, or you can use this formula for gradient, that is y2 minus y1 over x2 minus x1 if you are taking 2 points. That is, 1 point is x1 y1, and another point is x2 y2. Okay. So let us do question 7. A stone is projected vertically upwards from the ground at initial speed of 5 meters per second. Okay. Air resistance is negligible. These are very important keywords. So what is maximum height reached by this stone? Okay, so this question belongs to the kinematic section and dealing with the equations of kinematics. So what is given to us? This is projected upwards with speed of 15 meter per second. This is the initial speed, and you know that under gravity, its speed will decrease, and eventually, its final speed at the top will be 0 meter per second. Because in this case, gravitational force is acting downward, or the direction of acceleration is in the downward direction, and the direction of velocity is in the upward direction. So object will slow down. Okay, slow down, and the final velocity will be 0. So what we have to find? We have to find this height. So what will you do? You know that you have to use the equation of motions, as the acceleration is constant throughout this motion. So equation of motions are applicable, and what data is given to you? Initial velocity is given, that is 15 meter per second. Let's take upward direction as positive. So initial velocity is in upward direction, and we are taking as positive 15 meter per second, and final velocity is 0 meter per second. And acceleration is in downward direction, that is minus 9.81 meter per second square. So that's why we are taking it as negative. So this is in this motion, the object is having this constant deceleration. So what we have to find? We have to find height h. Okay, so you know that which equation is applicable. You already know that we have this equation: v is u plus at. This is first equation, and the second is s is ut plus half at square, and then 2s is equal to v square minus u square. These are important equations, and we have to find distance, maximum height, and we don't have time for this motion. So which equation we will use? The first equation doesn't give this displacement, second gives displacement, but we don't have time for this motion, and the third equation relates acceleration, displacement, final velocity, and initial velocity. So we will use this equation for this question. Okay, so 2as, s is height, that is v square minus u square. Final velocity is 0, and initial velocity is 15, so 15 square, and acceleration is minus 9.81 times h. So h will be minus 15 square divided by 2 into 9.81. We will bring this factor on the other side to make it subject. So this negative sign will cancel out. That is 15 square. Let me simplify this. 15 square divided by 2 into 9.81. So the answer to this question is I am doing, that is 11.46. So h is 11.4678. So what is the right option for this question? You know that the B is correct. Okay, so you cannot guess the answer B without evaluating, without using the equation. You cannot guess this answer. In these type of questions, you have to use the correct formula, and you have to simplify and evaluate the final answer. So B is correct answer. Question 8 is, what is meant by mass of an object? Okay, so this belongs with the definition of the mass of object, and you know that the mass is the property of object that resists a change in motion. So A is correct option. Okay, so why B is incorrect? The pull of earth on object, you know that pull of earth on object is weight of equal to the weight of object, that is mg, and that is not equal to the mass of object. Even you know that where gravitational acceleration is 0, then the weight of object will be 0, but the mass will still be there. Okay, So that's why this is incorrect. The total number of atoms in the object, you know that if you count total number of atoms in an object, that will not be equal to the mass of object. That will be equal to the total number of atoms. Okay, so so that's why this is incorrect. The weight of an object is also equal to mg, and that is not equal to the mass of object. Okay, so that doesn't defines the mass of an object. So this is straightforward question. You should know that the property of an object that resists a change in motion is known as weight mass of an object. Question 9. This is again very interesting question. The diagram shows two parachutists, X and Y, moving vertically downwards. Okay. So let's see what information is given to us. The total mass of parachutist Y and his parachute is twice the total mass of parachutist X and his parachute. So this is very important information, that mass of Y is twice the mass of X. Okay. And at this moment, the air resistance on parachute Y is twice the air resistance on parachute X. So if air resistance on parachute Y is 2 times air resistance on parachute X. So which statement describes the acceleration of Y compared with the acceleration in X? So we have to compare accelerations of two parachutists. And you know that first of all, we should know that there are two forces acting on each parachute. And what are these two forces? One is the weight of parachute that is acting downward, and other is the air resistance that is acting in the upward direction. Okay, so this is also again very important information, that neither parachutist has reached its terminal velocity. You know that at terminal velocity, upward forces and downward forces are equal, so net force is 0. But over here, neither of the parachutists has reached the terminal velocity, so net force is not 0. And what is the net force? Let me write net force for X. You know that this downward force is mg, that is weight of object, and upward force is air resistance. So if I write equation for acceleration of this parachutist X, that is downward force minus upward force, because the downward force is greater, so net force is in the downward direction. Air resistance of X is equal to mass time acceleration. This is according to Newton's second law, that net force is equal to the mass time acceleration. Okay, so this is for parachutist X, and you know that parachutist Y has twice mass and twice air resistance. Okay, so let me write equation for parachutist Y, that is equal to, you know that m of Y times g is downward force and air resistance of Y, so that is mg, m of Y times g minus air resistance in Y is equal to mass of Y time acceleration. Okay, so now let's use this information, that mass of Y is twice mass of X times g, and air resistance is also twice, that is 2 times air resistance of X, that is mass of this, that is 2 times mass of Y is 2 times mass of X times A. The second equation is acceleration in X, and this is acceleration in, this is acceleration in Y, and this gives you acceleration in X. So you can see that if I take this 2 common, then it will be cancelled with this 2, and I will be left with this equation mgx minus air resistance in x is equal, sorry, air resistance in x is equal to mass of x time ay. Okay, so you know that if I make this acceleration in y as a subject, then I will get this thing divided by this mass of x. Okay, and acceleration in x is this thing mgx minus air resistance in x over mass of x, that is acceleration in x. So you can see that from these two expressions that they are exactly equal. Mass of x time g and this is mx time g time air resistance in x over mass of x mgx air resistance x over mass of x, that gives you acceleration in y, and acceleration in y and acceleration in x, they are equal. So acceleration of y is same as acceleration of x, so B is correct option. So if you what is the basic idea that the mass of y and air resistance both are twice of this mass of x and mass of, sorry, air resistance of x and air resistance of y. So net force on y is twice the net force on x. Can we say that net force is weight of y minus air resistance of y, that is F net on y. Okay, so weight, mass is twice, so this means weight is twice, acceleration, gravitational acceleration is same at the same position, air resistance is twice, so this means the net force on y, F net on y, is twice F net on x. Okay, but you know that the net force is mass time mass of y time acceleration of y, and 2 times mass of x time acceleration in x, and you know that mass of y is 2 times mass of x. So that's why if net force is twice and the mass is twice, then the acceleration will be same. So you can also do in this way that acceleration in x and acceleration in y, they are same. So let's do question 10. The table shows 4 different collisions between 2 blocks. Each of mass is 0.5 kg. Which collision is perfectly elastic collision? So this question belongs to the dynamics section, and you know that perfectly elastic collision is that in which the total kinetic energy is conserved. Total kinetic energy of the system before is equal to the total kinetic energy. So total kinetic energy is before is equal to total kinetic energy after. And in elastic collision, momentum, total momentum is also conserved. So you know that in case of elastic collision, we have the very important relationship that if the collision is elastic, then relative speed of approach this was the final result, is equal to the relative speed of separation of 2 objects. Okay, so we have to check using this criteria. So let's check option A. This is moving with 4 meter per second and this is at rest. So what is speed of approach? You know that the speed of approach is 4 meter per second because this is at rest and this is approaching with 4 meter per second. And after collision, they are moving together. So if they are moving together, they are not separating from each other. So the speed of separation over here is 0. Okay, okay. So if two masses are moving together, then their separation is there is no separation at all. With respect to time, they are not separating from each other. So the relative speed of separation is zero, but the relative speed of approach is not zero. So that is this option is incorrect. So this is not perfectly elastically. Let us check option B. This is moving with speed of 2 meter per second in right direction, and this is moving with speed of 2 meter per second in left direction. So what is speed of approach? These two, if two objects are moving towards each other, then their speeds are added to give the speed of approach. So what is their speed of approach? In this case, their speed of approach is 4 meter per second, 2 meter per second plus 2 meter per second. And after collision, they are at rest. Okay. So this means that again, their final speed of separation is zero. So their speed of approach is not zero. So that's why this option B is also incorrect. Let's discuss option C. This is approaching with 2 meter per second, and this is so these two objects are approaching towards each other, and they are moving towards each other. So their speed of approach is 3 meter per second. Okay, and this object is after collision. This is moving towards left direction, and this is moving towards right direction. So what is their speed of separation? They are separating from each other when their direction of motion is in opposite direction. Then their speeds of approach becomes speed of separation is the sum of these two speeds. So that is 5 meter per second. What are you observing? That the speed of approach, that is 3 meter per second, is not equal to the speed of separation. So that's why it is also incorrect. So let's obviously D is correct, but let's verify that. This is moving with 4 meter per second towards right. This is moving with 1 meter per second towards towards right direction. Both are moving towards right. So what is speed of approach? This 4 meter per second is greater than this 1 meter per second. So they will be approaching each other. Otherwise, collision is not possible. So in this case, speed of approach is 3 meter per second. That is the difference of these two speeds. And after collision, this is moving with 1 meter per second. This is moving with 4 meter per second, and their direction of motion is in the same. So this this 0.5 kg is separating with relative speed of 3 meter per second. Okay, so their speeds of approach is equal to the relative speed of separation. So only D is correct. Okay, so if you have two options where speed of approach is equal to the speed of a separation, that is not the case in this question, then what will you do? Then first you will check the conservation of momentum. If in two options speed of approach is equal to the speed of separation, then in obviously in one option the momentum will not be conserved. So then you will check conservation of momentum as well. But in this question, out of these four options, only only in one speed of approach is equal to the speed of separation. So we do not need to calculate their kinetic energies before and after. Obviously, if you want to calculate the sum of kinetic energy before and after in each option, you will observe that in D, the kinetic energy of both objects before collision is equal to the kinetic energy of both objects after collision. I hope you understood. Thank you so much.